Hello, and welcome to our webinar on Donovan, Scale's AI assistant for the public sector. I'm Kathryn Harris, and I will be one of your hosts today. Scale AI accelerates the development of AI applications to deliver critical mission outcomes and efficiencies. We work with enterprises of all sizes across diverse industries, ranging from autonomy and robotics to global logistics to the federal government. More specifically, the mission of Scale's public sector team is to accelerate AI overmatch for the nation and our allies by delivering the most advanced mission-ready AI capabilities. Scale AI was founded in 2016 to solve the critical bottleneck of delivering high-quality training data to fuel the development of AI algorithms. At the end of the day, algorithms ranging from self-driving cars to ChatGPT, they all boil down to the data upon which those algorithms are built and continuously retrained. Because Scale takes an approach that combines automation with finely grained human expertise, we've been at the forefront of the most significant breakthroughs in artificial intelligence, including generative AI. We've been a proud partner with OpenAI since 2019 to help develop ChatGPT-2, and today, Scale continues to power every leading large language model, including those developed by OpenAI, Meta, Microsoft, Anthropic, and others. Our approach to fueling this generative AI revolution is threefold. First, we develop and fine-tune high-quality AI-ready datasets. Second, we build, customize, and deploy AI models and applications into relevant customer environments. And then third, we continuously test and evaluate those datasets and the models. Scale is a responsible AI industry leader, and we partner closely with the White House, with the National Institute of Standards and Technology, or NIST, and others to develop AI safety frameworks and technologies. Our T&E approaches include benchmarking and red teaming, along with supervised fine-tuning and reinforcement learning from human feedback. Collectively, this three-step approach leads to better data, which leads to more performant and trusted models, which leads to better and faster mission outcomes for our customers. As you can see here, we have a number of products across both our commercial and public sector practice in each of these areas, including Donovan as one of our AI applications. So let's dive more into Donovan. First, very briefly, why did Scale develop Donovan in the first place? Quite simply, to allow the US government to utilize and partake in the generative AI revolution so that it can continue to ensure US competitive advantage. We launched Donovan in May 2023, just last year, and it was the first LLM deployed on a classified government network. Today, it's deployed across multiple networks across the federal government. So what are the daily pains and challenges that Donovan seeks to alleviate? Simply, it's that public servants and warfighters are overwhelmed with too much data, they're task saturated, and ultimately left with partial information upon which to make critical mission decisions. I'm sure many of you who are serving in government or served in the past know this pain personally. I certainly felt it when I was in government, and many of our customers tell us every day how Donovan allows them to do in minutes what they previously took hours or days to do. So with Donovan, you have the ability to search through vast amounts of information, whether that's open source information, classified intelligence, or other proprietary government data. Donovan can quickly summarize that data for you and generate reports that are customized to your specific requirements, whether that's a certain format, a certain tone, or specific content that you want to highlight. And ultimately, you're able to uncover more insights more quickly with greater confidence. The bottom line is data overload, which everyone faces, degrades decision advantage, and Donovan can help. So I'd like to introduce my colleague, Ben Youngs, who leads our solutions engineering team, to walk you through how LLMs are built and get under the hood of Donovan a little bit more. Ben?
Thanks, Kathryn. Hi, everyone. Large language models like the GPT series, which stands for Generative Pre-trained Transformers, are now at the forefront of AI, powering applications from chatbots to content creation tools. At their core, LLMs are trained on vast amounts of text data. This training involves processing and understanding patterns in the data, learning from context, and even grasping nuances of language like sarcasm or idioms. The building process starts with collecting a diverse and extensive data set, often encompassing a wide range of internet text data from multiple sources, like Wikipedia, GitHub, Reddit, Common Crawl, etc. Then, Using a neural network architecture known as transformers, the model is trained. This involves feeding the model text and teaching it to predict the next word in a sentence, gradually improving its predictions over millions of iterations. Transformers use mechanisms called attention and self-attention to understand the importance of each word in the context of others, allowing the model to generate coherent and contextually relevant text outputs. After training, the model undergoes fine-tuning with more specific data to enhance its performance on particular tasks, such as translation, summarization, or even generating code. During the stage, an advanced technique called reinforcement learning from human feedback, RLHF, can be employed. RLHF fine-tunes the model based on human preferences, guiding it to produce outputs that align more closely with human values and expectations, which can improve interaction quality and model performance. So Donovan is model agnostic, which means we can bring commercial, open source, or even customer-built models into the platform. We continually evaluate and deploy new models as they are released. Donovan is also environment agnostic. That means we can deploy Donovan into customer security boundary where their data lives without any callouts or external dependencies. We've deployed Donovan to commercial clouds, sensitive environments like IL4, and multiple classified environments as well. Donovan also features models that have been fine-tuned for specific use cases and domains. One example of this is fine-tuning an open source model on Department of Defense language, terminology, and acronyms. Donovan addresses the concept of explainability and the concern around black box responses through a feature called citations. We'll show that in more detail during the demonstration. In addition to chat, Donovan also includes a customizable report generation feature, providing users the ability to generate structured and templated outputs from source data, helping users in accelerating writing tasks. You'll see this as well in a few minutes. One of the benefits of Donovan is being able to interact with your own data in the platform. You can do that from a simple local upload from your desktop. But we've also built Donovan to be able to integrate with other data sources via connectors and the Donovan API. So you can connect Donovan to interact with data that lives in cloud storage, databases, external APIs, and other sources as well. At a high level, this is how the Donovan platform works. Data is brought into the platform through local uploads or other data connections. That data is then processed by Donovan, extracting textual information and transforming that data into a representation that the large language models can interact with. We then store that information in that format for the model to utilize. This is called the embedding process. Once the embedding process is complete, the user can interact with that data in Donovan. That can be via chat with the model or things like report generation. Interaction is through prompts or instructions to the model. Relevant information based on the prompt is then retrieved and provided back to the model, and the model generates a response to the user. You can continue to iterate on that process through a chat thread in Donovan as well. The last step optionally is the process of improving models through fine-tuning. I mentioned this briefly a moment ago. This can be a critical piece in providing models that are performant and useful for specific domains and customer use cases. So let's spend a minute talking about how Donovan addresses weaknesses that are inherent to large language models. A consistent concern with LLMs is their tendency to hallucinate, essentially providing confidently wrong information. Donovan addresses hallucinations in multiple ways. When we evaluate models for inclusion into Donovan, one of the criteria we evaluate is a model's tendency to hallucinate. We do this through evaluation, through industry standard metrics established around hallucinations, as well as internally developed benchmarks and testing protocols. We also address hallucinations through the process of retrieval augmented generation, or RAG. When you bring data into the Donovan platform and add it to a data set, Donovan instructs the model to leverage that information when generating its response, instead of depending on information that was used during the model training process that may or may not be related to the information you're looking for. You'll see several examples of RAG in a minute. Finally, we've introduced the citations feature that I just mentioned. Citations provide the user with tools to see what information the model has used to generate a response. Another concern is around models being able to leverage domain-specific or real-time data. Donovan handles this in a few ways, primarily through the RAG process that I just mentioned, as well as the ability to integrate with external data sources through connectors and APIs. Finally, you'll often hear about models performing poorly on specific types of operations, performing mathematical calculations, understanding time and space, or interacting with structured data sets like CSVs or database tables. Donovan addresses these concerns in a few ways. Firstly, being able to evaluate new models as they're released against a variety of criteria and understanding how models perform in different operations. Related to that evaluation, taking the most performant models and making them available in Donovan, but also ensuring there's a diverse collection of models available that excel at different things. Things like general purpose content generation, instruction following, code generation, or math, and then selecting the right model for the use case. Finally, Donovan also has the ability to interact with purpose-built tools that might be better suited for specific operations. So think about being able to call a routing service or interact with an external database or API.
Wrapping up as we head into the demo, just a few quotes here from our different customers and end users. As I mentioned, Donovan's deployed across multiple networks, across multiple DoD components, combatant command services, defense agencies, as well as other federal customers. And really what you can see here is the ability to accelerate workflows, leverage much of the data that is latent within the government right now, and generate mission outcomes much faster. So Ben, over to you for the demo.
Great, thank you, Kathryn. So this is the Donovan user interface and the home page. Here you can start a new thread with what we call base chat without providing the model any specific information to use in its response. So you can see a very generic response from the model here without providing any additional information. When I switch over to the datasets tab, you can see there are no datasets selected. You can also see any prior threads that you have in the platform. So if you've been in the platform before, you can see your historical threads. When I pick a prior thread, you can see that the full thread history is retained, and I can jump back into that session as desired. Donovan can also suggest data sets. So what you'll see here, in this case, I'm asking a question about cyber attacks on Ukrainian telecom companies. And you'll see here in a moment, you get a fairly generic dated answer. And there's your generic answer. However, if there is relevant data that's been loaded into Donovan, it may suggest one or more data sets that you might want to leverage. So you'll see here in a moment. In this case, I have a specific data set on Russian cyber operations that's relevant, and it gets suggested along with a few other data sets. I select that, it reruns the prompt while leveraging that info from the newly added data set. And then you can see from the regenerated response that more recent information from cyber attacks is included in the response. Donovan will also show pre-configured prompts that may have been set up for a data set. So you could see just clicking on one of those individual data sets. You jump right into a session and submit the prompt to a model. Once that's finished, let me show you where that can be configured. Long response here. So when you look at the properties for a specific data set, there's a section for suggested prompts. And this is a totally optional step. You can see there's some general information about the data set, and then you can see where we've actually saved prompts. Again, this is a totally optional for each data set. So let's talk about orgs and workspaces. So Donovan uses the concept of organizations and workspaces for role-based access control and isolation of users, data, and use cases. Each user belongs to a single organization. This is configurable, and you can think of this as a way to keep different organizations separated in the Donovan platform. In addition to organizations, Donovan also leverages workspaces, which you can select from the workspace dropdown on the top left side, as you saw. And each user has access to at least one workspace, but you can have access to multiple workspaces within an organization. You can see the specific data sets that exist under each workspace. So here you can see the model cards where you can identify the specific models that are within Donovan. You can select specific parameters and search for specific parameters. This includes open source models, it includes commercial models, and it also includes fine-tuned models. You can also filter on specific parameters to find the model that you're interested in that does a specific thing or is aligned to a specific purpose. And then you can actually go and select and switch to a model, which you'll see with the icon there. So within data sets, you can sort data sets based on A to Z or the time that the data set exists. What's important to think about with data sets is they are essentially a bin for providing context to models. So in this case, you can see we've loaded data into a data set. There's some general information that's been actually automatically generated from that data set specifically, or for that data set specifically. You can see the saved prompts for a data set, which I showed a moment ago. And you can actually see the individual documents that exist for a data set as well. Importantly, we also maintain these documents. You can also delete here as well if you need to actually do some data cleanup and those sorts of things. We also maintain classification and the status of the data upload as well. We also maintain the original document in its native format. So in this case, we have a PDF. That comes in handy for a variety of reasons, but we use that for our citation capability, and that we'll talk about that in a moment as well. Here you can see a specific data set being leveraged, and we'll go into the process of actually uploading data. So there's a wizard here. You provide some information around whether it's a multilingual data set or not. That has implications for how we process the data, if there are any saved prompts you would like to use, and then also a name and description for the data set. So in this case, I'm just generating a saved prompt that can be reused after the fact, and we'll save that. Provide a name for the data set, and then provide a description. Apologies for the slow typing. Hit continue. And the next page here will actually get into some of the parameters of how you upload data to the platform. So we have options for local data uploads, as you can see at the top section there. We also have the ability to bring in data from cloud sources. So think of cloud storage and the like. In this case, we'll just bring in some local data that we have. We support a variety of different file types. They all have to be text-based file types. So those are things like text files, PDFs, docx, those sorts of things as well. In the platform, once you've selected documents, you'll see actually the documents you've selected. You'll see the type, you'll see the specific file name, and you'll see kind of where it's at in the status. We haven't processed anything yet. In this case, we can do a bulk classification of documents or individual classification. Obviously, in this environment, everything is unclassified, but you can use that to select all of those files. And then once you're done, you can process those files. So under status, you can see that these are now processing. And generally within a matter of a few minutes, these documents, depending on how large your data set is, generally those documents will be available quite quickly. I'm going to just jump quickly to an existing data set here so you can see there are actually 24 documents in. They've all been loaded successfully. And then you can select that data set and jump right into a chat session. So in this case, we'll use a very basic kind of question. This data set is related to the Tower 22 attack in Jordan. Very simple question, just asking about the attack and some of the other criteria about that attack, including location, date, time, etc. And then you can see within a matter of minutes, we're actually leveraging data that we've brought into the platform. This is relevant to the Tower 22 attack, and we can have the model generate these responses using that data very quickly. So let's go into another chat example here. This is related to supply chain, Russia's supply chain for drones, primarily provided by Iran. So you can select that data set and then jump directly into a chat session. So based on the documents provided, just give me an overview. What types of Iranian drones are being used by the Russians in Ukraine? Very simple prompt to the model, and the model will provide a response based on that prompt you gave it and the information that's been provided in your data set. So you can see there's a high-level overview of the Russian drone use of Iranian drones in Ukraine. Very simple question there, but you can iterate on this chat session. So I'll ask a follow-up question here. So what else can you tell me about a specific type of drone, the Shahed 136, which was mentioned in the prior question? So a follow-up on that, you'll get additional information, some more context around the Shahed 136 drone. And you can see it's a pretty good response here. There's probably some formatting things that you'd like to change, but it's the model providing that information back to you. So I'll ask another follow-up question here. So you can iterate on this process. You can continue to ask questions. You can refine your questions. This chat session persists, and you can continue to iterate on this process in your chat session. So great. Couple basic examples here of fairly straightforward chat interaction with a model based on data that we've brought into the platform. All very simple questions. You can be as detailed or as simple with your questions as well. Now here are some examples of content generation. So not just asking a question, but in this case, I'm asking for a 2-paragraph summary on Russia's use of drones. So giving more specific instructions to the model in terms of the question we're asking and how we want that information provided back. So you can see you get 2 pretty clean paragraphs there, just what I asked for. We also have the concept of citations that I mentioned before. So essentially what we're doing is identifying information from that data set that is relevant to the query. So we'll identify cited sources, so essentially pieces of text that we've identified from those documents specifically that were part of the response, and a link back to the original document where that came from. So you can see there's a PDF here. So those are cited sources. You can also see consulted sources. So similar, but different in the fact that these were documents that were reviewed as part of the kind of retrieval process, but weren't ultimately used in the generation. So you have those 2 citations. So going back to the content generation example, very specific, give me 2 paragraphs. Let's be a little more specific here. So let's provide a bulleted list of the information that we're looking for. So looking for a bulleted list of these specific drones. So again, you can be as detailed as you want to be in terms of the question you're asking, in terms of the format or the structure that you want to use, the output type. And that can actually really have quite a bit of an impact on the types of responses you get from the models in your chat sessions. So you can see I asked for a bulleted list that responded to my query here and responded with a bulleted list of different drones, also including the manufacturer. So let's get into maybe a more complicated example here. So giving very specific instructions, giving it a persona, saying you're an intelligence officer, focusing on Russian invasion of Ukraine, use a neutral tone, leverage the documents I gave you. And then I'm also telling it specific information that I want it to use, where they're being sourced from, different types, etc. And you can see based on that instruction, it actually provided specific sections, sourcing, actions, specific countermeasures that Ukraine is using as well. So you can even be very detailed in terms of the information that you want the model to provide back. Generally speaking, the more detail you provide in the prompts, the better your responses will be. There's also an example here of some reasoning capabilities. So give me a summary of contradictory information that exists in the documents provided. We get a lot of questions about that. We can do that sort of thing to analyze documents as well. So I'm going to select another data set here, just a single document. This is an example of natural language processing. So people have built tools to do this sort of work for a long time. I asked that extract all the entities that you find in this specific document. It's a news article, and it can extract all of these things, maybe in kind of a messy format, but useful nonetheless, especially if you need to be evaluating a lot of different data as it comes through the day. You can extract that information. But I think we can improve upon that. So let's update the prior response, include relevant details about each entity, what's the context they're used in, and you'll get a more cleaned up response here. So gives you a better list, cleaned up, actually provides context, provides essentially why it was extracted and how that's related to the overall topic of the article. So really useful here for kind of triaging data as it might come in. We talked about formatting a little bit. This is kind of an interesting example here, but in this case, I want to extract all those entities, but I want to turn those entities into a JSON file or object. So you could use this converted into more of a machine readable programmatic kind of format. So probably not perfect, but this generates a JSON output that you could use. Really useful when you want to actually convert this data to put it into other systems like a database or something like that. So let's do some topic modeling. Based on that document, provide me a list of top 6 most relevant topics. So you get that from the model. Specifically, it'll give you the list of 6 and what those topics are. It gets better here. It gets more interesting. You can even do additional things. So I actually want to have it just provide me topic words or phrases. So clean that up a little bit. So there you go. There's your 6, just with very kind of concise topics there. And I think we have one more example here where I'm going to give it essentially a taxonomy or a list of topics and say, choose based on the topics I provide, choose the 6 most relevant topics. And then you'll see based on the list, so it talks about international relations, government, economic indicators, trade, etc. So you can do some really interesting things with natural language processing straight out of the box with these models within the Donovan platform. Another thing that we can do here, this is a data set that features a bunch of native language, Mandarin language, academic technical resources. So you can see I don't speak Mandarin. You can see those are in foreign language. But what's very interesting about this is that we can use English language to ask questions or to interact with this data without having to do any sort of pre-processing steps. So I'm asking a question about technology readiness level around hypersonic technology. So essentially the response is, I can give you an assessment, but I can't really give you a technology readiness level. The important piece here is that we're asking English language questions against a Mandarin language document or set of documents, and then we're getting responses back in English as well. So you're avoiding the machine translation or any of those kind of pre-processing steps that would be traditionally required. Another example of reasoning, again, asking kind of what would China need to do to advance their hypersonic efforts. Again, asked in English, responded in English as well. And you'll see the citations that we talked about before, so you'll still get those citations even though they are in Mandarin as well. And you can see the specific document or documents that are referenced in this response from the citations. So you can click on the specific kind of piece of the document where that information comes from. You can also jump back into the source document in its native format. So let's talk about report generation at a high level. Essentially what this is taking source data, primarily unstructured data, and being able to generate templated structured outputs. So I have a pre-existing report here that we'll go through and kind of regenerate this just in the interest of time. You provide the topic, you specify the data set that you want to use that's going to provide that context. And then you can specify per section instructions for this. So I'm asking for an introduction. I'm asking for details. If there's any information about casualties, again, this is related to the Tower 22 attack in Jordan from a few months ago. Asking about casualties, specific if anyone took responsibility for that. Those are all kind of individual prompts. And what we're doing then is Donovan is actually going to go in and take the prompts that you provided for each section, ask a variety of related but additional kind of different questions to try to pull as much relevant data into this report as possible. So you can kind of see some of those other questions, other prompts that are generated by Donovan, and all of that information is kind of pulled together to generate this information for the report. And so you can see here we have a structured report with an introduction, with details, with casualty information, with the likely perpetrators, location where it happened. We include citations here as well. So just like in chat, you actually get citations that are relevant. But importantly, we can also go in and refine this document after the first iteration of it. So let's change the section about kind of reactions, and let's make sure we include any information that's relevant to, has anyone taken responsibility for the attack? Let's include that in the section as well. So it's not a final document until you want it to be final. You can iterate on this process, adjust specific sections, or adjust the actual overall report as well. So you can see same sort of process that's going through and generating those specific prompts that are going to be used to help provide that response in the section here. And so you can see the only section that actually changed was under likely perpetrators. And you can see there's an extra section there that's worth noting. No group of individuals has officially claimed responsibility. So you can go and iterate until you're comfortable with the report generation. Once you're finished, once you're happy with it, you can export it to either a Word document or, in this case, a PDF as well. And then you can save that. So the report will be live. You'll be able to get back into it after the fact if you wanted to make adjustments, or you can make modifications after the fact. That's report generation. Finally, just want to talk very quickly about some of the resources here that are in the platform. So we have kind of a walkthrough, if you will, that allows users that are new to the platform to kind of click through specific instructions, get you up to speed with the platform, that sort of thing. You can also go to the online Donovan documentation, linked straight from that Donovan link that you just saw. So this is all of our documentation for the platform. You can understand how to use it. You can understand kind of the different components of Donovan. Another useful piece here is the API reference. So for folks that are developers that want to interact with Donovan via our APIs, we provide that capability. And there's a 0 to hero kind of start to finish type exercise that you can go through that starts with authentication, takes you all the way to loading data, actually interacting with that data and getting data back from the model in your own application or in your dashboard or something like that. So everything you can do in Donovan through the user interface, you can do through APIs, and all of that's documented and very testable. So in this case, you can test interaction with Donovan via shell or your language of choice. I think it's Python selected here, and you can actually test out these specific components as you're developing. So that's our demo. Thank you for watching this demo. Really excited for any questions that folks have.
Awesome, great. Thank you so much, Ben. We do have some live questions that are coming in, so thank you to everyone who's dialed in live for submitting your questions. Please continue to send them. We're going to start with one that the question just is, this is great, but can't I just do this in-house and create my own sort of custom GOT solution? And the answer is you absolutely can do that. However, there are some, what we found, really unique requirements that a lot of government end users desire and need that can be intensive to build out and also really hard to scale at the enterprise level. Yes, you can build sort of a custom one-off solution, for your own use case, but for really large commands and agencies and organizations, those enterprise capabilities are something, as you might guess from the name of our company, that we really excel at. And so I'll walk through a couple examples of what that. First is bringing the data in. I talked about kind of data engine and curating and annotating and fine-tuning data and getting large volumes of data ready to feed these models and feed these applications. So that's one area that we put a lot of emphasis in because we see it as a requirement for large federal agencies and commands and organizations that they need that. Another one is, as Ben had mentioned, being model agnostic and infrastructure agnostic. As Ben demonstrated, we have a lot of models already in the platform. We have relationships with many model builders, both commercial, academic, public sector, and we can help bring your models in as well. And then being able to deploy on different clouds or different types of infrastructure. And additionally, as you saw in the demo, we spent quite a bit of time building out functions and capabilities, again, that our federal customers are asking us for. I'll give you a couple examples. Citations, and not just a single citation, but multiple citations. The user interface is very customized to how a federal program manager or an Intel analyst might need certain templates and formats and how that might interact with the unique workflows of the federal workforce. And then again, also managing the data and the data sets and the API connectors at scale for those enterprise use cases. So that's what we're really focused on. A lot of the experimentation that's going on across government, I think, is a really important learning moment for many federal employees and military service members and sort of the national security community. But for large scale enterprise LLM capabilities, we're really proud to offer what we showed you today. So let's go to the next question. And Ben, I'm going to hand this one over to you. Question says, I'm wondering how the QA/QC process happens to vet different use cases. Getting the conclusions correct is critical and can be really hard.
Yeah, for sure. I think we think of QA and QC from a couple different kind of components. So that starts with the evaluation of models before we bring them into the platform, ensuring that the models are performant against the use cases that our customers want to use them for. So not trying to apply a general purpose model to very specific use cases, or identifying models that are good at the specific things that our customers are asking for. So it kind of starts at that process there. There's a variety of other kind of ways, like we talked about citations and iteration with prompts to ensure you're getting useful and accurate information through your responses. So you can evaluate the citations, you can evaluate the the source materials that we maintain and link to ensure that it's pulling relevant information. That's kind of in platform, right? But beyond that, there's also the ability to evaluate the model performance kind of in a more programmatic sense, being able to test these models against specific prompt and response pairs. So essentially providing ground truth to these models and evaluating the ground truth, that the quote unquote correct answer from these models, comparing that to what the model actually generates as well. So we can compare kind of the ideal response from a model to what the model is actually generating. So we can evaluate that, determine how it's performing in that regard. And then we can also, if it's underperforming or providing inaccurate information or something like that, we can perform fine-tuning steps to actually kind of improve the process of the model itself, and being able to handle specific scenarios, specific prompts more effectively. So long answer there, but a variety of different kind of ways we approach quality control for these models.
Excellent, great. So another question that's come in says, what's the future of Donovan? Where are you headed? What capabilities are you building? What can we expect in the next year? And I'll kick it off, and then Ben, hand it over to you to add more. So two big areas that we're focused on right now is end user configurability. So that can be the custom report generation, different models, different foreign languages, also different ways in which Donovan interacts with existing systems. Something that we hear often from our customers is that they already have a ton of tools to log into. Current, government workflows are very labor intensive, lots of systems to log into across different networks, a lot of copying and pasting across systems. And we certainly do not want to introduce more friction and slow those workflows down. So one way that we're working with customers is how do you take Donovan and feed it as an API into another existing system, so that the end user gets the benefit of all the capabilities that Ben showcased, but doesn't add yet another thing to log into. And so we're working with a couple of different companies and government programs to integrate Donovan in that way, and we're looking forward to doing more of that. Another one is more custom data sets. Again, there's a ton of open source information that's available, that's out there, that government users are accessing. So how can we bring that into Donovan, as well as government APIs into Donovan as well? There's a lot of latent data of different modalities all across the federal government, and how can we help the government tap into that and bring that data in? Ben, are there other?
Great response. I think I share a lot of the same kind of excitement about some of those features. I think of three big things. I think of connection or connectors to different sources. So as Kathryn mentioned, we don't need to introduce another tool, but allow Donovan to integrate with existing data sources, with APIs, with other platforms, and have that exist out of the box. We also think about Donovan as a platform, so not just chat per se, or not just report generation, but Donovan as an orchestration tool, where you can use the capabilities of large language models within Donovan to do those sorts of things that we showed already, but you can also use these models to help orchestrate complex multi-part processes. So doing natural language processing, but also being able to call out to external tools to pull data back, be able to do processing from other components as well. So expanding beyond chat, for sure. I think the final piece that I'd mention is just the continuous evaluation of models, so the testing and evaluation that we're doing within the platform. So it seems like every week there's a new model that is the open source kind of leader from a performance standpoint. So we put a lot of hard work into evaluating all of those models as they come out. When appropriate, bring those into the platform. And then the second kind of piece of that, the flip side, is being able to have a consistent way to test these models, and then being able to fine tune the models to do the reinforcement learning type work to provide ultimately better performance, safer models, all of that sort of thing as well. And you'll start to see some of those components in Donovan, in the coming year here.
Excellent. Great. Thank you, Ben. Okay, so to wrap us up, you may be wondering, this is great. How do I get my hands on Donovan? How do I experiment with this? If you are a federal employee or a contractor working on behalf of a federal customer, you are welcome to sign up for a free 30-day Donovan trial. If you go to our website, scale.com/Donovan-trial, you can sign up there and put your hands on keyboard, upload your own documents, interact with chat, interact with report generation. We've got folks available to help you onboard, walk you through the process, learn how to access and play around with Donovan. So I encourage everyone to please check that out. We are also available on TradeWinds. So CDAO did a pre-competed OTA, and we are available to be purchased via TradeWinds, and that's up on the CDAO website as well. So that's a easy contracting way to get access to us. And you're welcome to reach out to any of us directly. The best email address for direct outreach is just federal@scale.com. That'll come to me and Ben and others, and we'd be happy to follow up one-on-one if anyone has additional questions or wants to learn more.